Assalamualaikum warahmatullahi wabarakatuh. My name is Alia Binti Mohamad Zailani, matric number CE190192 from Group A 5.4, Section 5. In this Chapter 5, AC3 Phase 2 for Synchronous Motor Lab Session, I will take part to explain data collection for activity 6 and 7 and results for equipment arrangement for star connection and graph in activity 8.
Good day, doctor. I'm Tharnisha and my matric number is CE190099. So today I'm going to continue the presentation on the results obtained in activity 8 and also the discussions of the data.
So we start with data collection for activity 6 with star connection. Based on the table 5.1 for data collection data of star connection, we got constant speed with 3000 RPM applied from 0 to 0.7 Newton meter. Because of this synchronous motor applied three-phase supply, we have taken reading for each phase, which are represented by red, yellow, and blue. As we can see the table, the readings for the voltage of each phase were recorded approximately between 141 till 145 volts. For current reading, we get average of each phase is 0.4 amps till 0.95 amps. And readings recorded seems to increase for total three-phase line current. Power reading were recorded approximately between minimum 31.5 watt and maximum 108 watt. The power factor obtained recorded a minimum reading of 0.47 to a maximum of 0.85. The table of data collection for amateurs show that the highest DC voltage was recorded at a load of 0.7 Newton meters and the lowest voltage at a load of 0.4 Newton meters, while the DC current obtained was 2.519 amps and 2.449 amps. For the calculated horsepower table, we get an estimate value between 0.148 to 0.442 by using the formula horsepower equal power divided by 746. Next, we continue to data collection of activity 7, which data connection. Same goes to the star connection. Speeds are recorded at 3000 RPM ranging from 0 Newton meters to 0.7 Newton meters. For voltage, the values are taken in the range of 139 to 144 volts, while for current, the data ranging from 0.52 to 1.54 amps. For power, we found that the range from 34.1 to 126.7 watts, and the total power of the three-phase increased from 100.1 watts and 308.8 watts. Then the power factor data is recorded 0.57 to 0.96. And the reading for the total power factor three-phase shows that the reading increased at 0 to 0.6 Newton meter load. Collection of amateur data. For data connection, the DC voltage was recorded a low value of 13.220 volts and the highest value reading is 13.348 volts. For DC current, the highest reading was recorded at a load of 0.3 Newton meters. The horsepower calculation for the data connection use the same formula as the star connection, which is horsepower equal to power divided by 746, and we find the value increase ranging from 0.134 to 0.414. at a load of 0.8 Newton meters, the reading for voltage, current, power, and power factor are uneven for both connections, either star or delta, because at that point of load, the motor was reached maximum torque. Last but not least, equipment arrangement layout with star wiring connection probably look like this, which we have a set of power meter here to measure the three-phase power factor, line current, voltage, line to line, and three-phase power. We have motor drive here, motor assembly panel here. We have three-phase supply. We have digital emitter and voltmeter, and analog emitter and voltmeter, and DC supply. Red, yellow, blue phase and neutral connected from three-phase power supply to a set of digital power meter. Then from digital power meter connected to motor drive according to their own color. The motor panel has a carbon brush or positive terminal connected to the digital DC emitter. Then from the digital DC emitter, one probe is connected to the analog DC emitter. From analog DC, voltmeter is connected to DC supply, then digital DC voltmeter according to their respective ports. The negative terminal from motor panel is connected to the DC supply and motor are ready to
So
operate.
first of all, as we can see in the slide is the delta connection layout. So what we can see is the connections are almost similar to the star connection we have done earlier, but the changes were made at the neutral wire, which is at star we have neutral wire, while in delta we didn't have neutral wire, and also at the stator connection. So from the three phase, we can see this is the three phase supply. The outgoing is to the measurement instruments, which is voltage, current, power, and power factor. Next, from the power factor, the outgoing is to the stator of the motor. So we have changes at the stator connections, which I will explain in the next slide. Then what we can see here is the DC supply. The DC supplies are given to the rotor of the motor. So as I told earlier, this is the connections or coil connections of the stator in the motor. So what we can see is that the differences are at the outgoing and also incoming. So what we can see is the outgoing of the stator will be connected as the outgoing of the red phase to the yellow, while the outgoing of the yellow phase to the blue, and finally the out phase of the blue to the red phase. So this is the changes in the stator connections, which is like RY, YB, and also B and R. So we can see here is the DC power supply. It's connected to the carbon brushes, and we have RYB, and there's a voltmeter connected between R and Y, while there's an ammeter connected between blue phase and also stator. So this is the connections of the delta, and also we can see that the outgoing of the blue phase is connected to the common 2. Okay, now I'm going to continue the presentations regarding the discussions on in the laboratory session. So in this laboratory, the activities of AC three-phase are two-pole synchronous motor. There are two circuit connections were tested. So in the first activity is the star circuit connection were made for the rotating field of the synchronous motor, while for the second activity, the circuit connections was for delta. So for both of these activities, several data were obtained and recorded, such as the motor speed, voltage, current, and power, and also power factor, which was explained earlier by my partner Alia. So for the three-phase horsepower, there were calculations were made by using the formula of three-phase power divided by 746. So the data were recorded for the connections separately by varying the load values from 0 Newton meter to 0.8 Newton meter, which was manipulated by using the friction or also Prony brake, while the motor speed was maintained throughout the session, as the synchronous speed of the two-pole motor was 3000 rpm. They also can be calculated by using the formula of 120 multiplied by the system frequency of 50 Hz and also divided by the number of poles. So as for this case, the number of poles are 2 and we obtain a synchronous speed of 3000 rpm. Okay, now let's go to the star connections, data analysis, also discussions. So the results are as shown earlier. So from the results obtained, it can be analyzed that the single phase voltage will remain in the range of 141.3 volt to 146.0 volt as shown here for all the load values, while the three phase voltage values were recorded in the range of 247.8 volt to 249.4 volt. Next, for the current, power and power factor shows an increment or increases as the load value or the power value increases. So from here what we can see is the maximum pull out torque or also the maximum load that the motor can manage is at 0.8 Newton meter. So for the 0.8 Newton meter of the maximum torque, we can observe that the readings are getting uneven compared to the previous readings obtained for 0 until 0.7 Newton meter load values. Whereas for the readings of the armature, for all load values were in the range of 2.515 ampere to 2.638 ampere for the DC current, while the DC voltage were recorded in the range of 12.897 volt to 13.048 volt. So this result for status shows that the values will remain constant even the load values were varied. So then a horsepower of the motor was influenced by the power values. So what we can see is the horsepower increases as the power value increases. Okay, next I'm going to explain on the results obtained for the delta connections. So based on the results obtained, it can be analyzed that the single phase voltage will remain in the range of 148.0 volt to 141.5 volt for all the values, while for current, power and power factor readings, the value increases gradually as the load increases till the motor reaches the pull out torque or the maximum torque. Thus, when the motor reaches the pull out stage during the load value of 0.8 and Newton meter, as in the star connections, the parameters are starting to become unstable compared to the results obtained from 0 to 0.7 Newton meter. So whereas the readings for armature for both voltage and current were in the range of 13.165 volt to 13.387 volt. So and for the DC currents, we can see that the values obtained were in the range of 2.462 ampere to 2.599 ampere respectively till it reaches the maximum torque, and once the motor reaches the pull out situation, the voltage and current at the armature escalates or becomes larger to 16.621 volt and also 3.306 ampere respectively. So whereas as similar to the star connections, the value of the horsepower shows an increment as the load value increases as well as the power increases.
Finally, results are from activity 8, which is graph for both star and delta connection altogether. As we can see here, both graphs of calculate horsepower versus load torque for star and delta connections were increased until 0.7 Newton meter and then decreased. AC current sector RYB, red, yellow, blue versus load torque graph, we can see the graph for delta connection went up dramatically after which 0.7 Newton meter load, while star connection went up slightly. And the last one, we have DC current versus load torque graph. DC current for star connection grow gently, but DC current for delta connection rose steadily. So I think that's all from me, and I will pass to my partner, Tanisha. Thank you.
Last but not least, the results or the graphs are explained earlier by my partner. So in these discussions, I'm going to explain what are the graphs all about. So based on the result obtained, we analyze further by plotting the graphs for the calculator horsepower versus load torque of star and delta connection, AC currents RYB versus load torque, and also DC current versus load torque as shown in these figures. So, for the first figure of the calculator horsepower versus load torque, we can see that the horsepower calculated was linearly related to the load torque because as the load increases, the power increases. Thus, the horsepower also will increase. But once the motor reaches the maximum torque, the power decreases, thus affected the value of horsepower too. So then, in the figure of AC current versus load torque, what we can see is that the value of AC current of the motor stator increases as load increases and it eventually fluctuates when the motor pulls out or stops at zero point 0.8 Newton meter. So finally a graph of DC current against load torque at the motor armature shows that the value will remain constant in both the connections at approximately of 2.5 ampere while the current values was the highest in delta connection with a value of 3.306 when the synchronous motor reaches the maximum load value or also the pull out torque condition and then the motor stops running. Hence on the overall we can see that the synchronous speed of the motor was remain at constant of 3000 rpm from load 0 Newton meter to 0.7 Newton meter, while at the maximum torque of 0.8 Newton meter, we can see that the motor stops running, thus shows a 0 RPM. So that's all from me. Thank you.